Please turn on your camera so that I can put you in the spotlight. Turn on your camera as well. Also, Grace.
Wait, sir. Okay.
Okay, yeah. Okay, you may start your presentation anytime you are ready.
Okay, I'll start now. Good morning, everyone. So today we will discuss about the ionic bond that this particular chemical structure have, which is ionic bond. Its name is calcium oxide. So calcium oxide is a key ingredient for the process of making cement and glass ceramics. So it is formed from the limestone, and then it produced like this bubuk. What is it called? Yeah, and it has some properties, and Tanita will explain about the properties.
So first, the property, as we can see on the top, yeah. It has a low melting point, which is about 2 degrees Celsius, and a high boiling point, which is around 2,850 degrees Celsius. It means that the bonds are stable, as we have studied earlier, that ionic bonds are stable, and it will be hard for them to change to change their state. And then the second property is the thermal coefficient of expansion. As we can see, this number here is around 11.5 until 17.5 times 10 to the power of -6. It means that calcium oxide has a very, very low coefficient of thermal expansion, and it means that it is very hard for them to expand. It also means that they are stable. And for the comparison, I've searched that the linear thermal expansion of polymers are around 10 times to 10 to the power of 5. It is the thermal expansion of polyester. And for the last one, it's the Young's modulus. The Young's modulus is 30 GPa. It means that the calcium oxide is very stiff and it couldn't be stretched. On the other hand, I've also searched the Young modulus of polymers are around 0.01 until 10 GPa, which means that they are stretchable. Yeah. So that's the difference between calcium oxide, which is ionic bond, and polymers, which is covalent. So I think that's
okay. And the last thing is this is the structure of the calcium oxide. So it has double bond, and yeah, that's the things that we want to share. Thank you so much.
Okay, thank you, Ezra and Grace. Are there any questions from the other group, Andy and Angeli, perhaps? Do we have any questions?
No, sir.
Andy, any questions?
No, sir.
Okay, I have one question. Why do they make ionic bonding? What makes them bind using ionic binding rather than covalent, for example?
Because calcium it has iron, and oxygen is also has some say similar electronegativity, so it makes the ion bonding rather than covalent bonding.
So if
and
you mean their
and the calcium
electronegativities are the same or similar?
no, similar. And the calcium has ions 2+, and the oxide has oxygen has
-2.
-2, so it combines.
Sorry, salah.
Yeah, that's why.
So it combines and
No,
become more stable.
they actually have ionic bonding forms when elements have different electronegativity, like different. The Ca2 plus is at the left side of the periodic table. It means that it has a low electronegativity and it tends to give electron, while the oxygen has a higher electronegativity and it tends to receive electron. So they bind together to become more stable.
So their electronegativity are similar or very different? Which one?
Different.
Very different. How different? Can you check?
Can I search the internet?
Yes, of course.
Okay.
You can see the slide that I presented in the previous hour. What is the electronegativity of calcium and what is the electronegativity of oxygen?
The electronegativity of calcium is 1. Wait.
I'm sorry, I really.
Well, oxygen is 3.44 ini. 44. I'm not sure ini benar atau enggak.
Oxygen is
44.
44. Okay.
Oh, two. Based on, oh yeah, based on your PowerPoint, the oxygen has 3.5 and the calcium has 1.0.
Okay, so they have 2.5 difference in electronegativity, right?
Yeah.
Yeah, that's what makes them to bind using ionic bonding. Okay, thank you for group 1. Okay, so let's continue with group 2. Yeah, Andy and Angeli. Angeli, could you please turn on your camera? Wait. Ya. Tidak bisa ya? Sebentar. One moment. Andy, spotlight. Angeli, spotlight. Okay, yes, you may start at any time you want.
Okay, so good afternoon, everyone. My name is Andy, and with Angeli, we're going to give a presentation about graphene. Okay, so graphene is an allotrope of carbon that exhibits two-dimensional metallic bonding. And the amazing thing about this thing is graphene is 300 times stronger than steel, harder than diamond, a fantastic conductor of heat and electricity, and super flexible to boot. Okay, so because of its metallic bond, they display certain properties, such as the first one is electrical and thermal conductor, as I said before. So electrons in the electron C are free to move and carry charge, as well as transfer energy from the heat source.
And the next property, graphene is also ductile because meaning that it can be easily bent without breaking. And it is also malleable, meaning that it is easy to shape into other different shapes because the bonds in the metallic bonding is easily broken and reformed, making it very flexible to shape into other things. And next, they also display a metallic luster, meaning that they appear shiny because they are opaque once a certain minimum thickness is reached, and the electron C that is present in between the metallic bonding reflects photons of the smooth surface. And other properties, because they're metals, because they are metals, the strong attraction between the atoms makes them strong. They have high density, high melting point, high boiling point, and low volatility. And that is all for the properties of graphene. Thank you.
Bravo.
Okay, thank you. That is interesting presentation actually, yeah. Interesting material, graphene, a material which has, I think, won Nobel Prize in the year 2007 or 2004, I forget. Yeah. Are there any questions from Ezra or Grace towards group 2?
No.
Ezra,
No, sir.
are you sure?
Yes.
Okay. My question to Andy and Angeli. So carbon is normally can be considered as non-conductive, right? So you mentioned that graphene is one allotrope of carbon material. What is allotrope, and are there any other allotropes of carbon?
There are, I guess.
What is allotrope then? What is the definition of allotrope?
The very big structure made of carbons, some sort of something like that.
Okay. What are the other allotropes of carbon besides graphene?
Besides graphene, what? Carbon.
It was mentioned actually during some slide of my presentation.
Is it? Is it diamond?
Yes, yes. Diamond is one of the other allotrope. Andy, why are you just smiling and you have to contribute?
I'm not
to
sure,
both.
sir, about
Yeah.
myself.
It doesn't matter if you are not sure. Just answer. We are still all learning. Okay, so yeah, but you mentioned like diamond, for example, may not be that conductive, yeah. But graphene can be conductive. And if we studied, yeah, from our study about metallic bonding, it happens because of there are clouds or sea of electrons that functioning as the charge carrier, yeah, for electricity. So in the case of graphene, how can it occur, yeah, this charge carrier of the sea of electrons in graphene, which is normally not, maybe do not exist that much in carbon-based material.
Carbon.
Because
Carbon is made of graphene is made of a lot of carbons, and carbons usually carbons they have electrons on the outer shell because they are their extra electrons, they leave the atom, so the carbon itself becomes positive. The carbon itself becomes a positive ion, but they are surrounded by a lot of electrons.
Yeah, that occurs mostly in the metallic elements like aluminum, iron, or like that, because the electrons in the outermost shell is maybe just 2 or 3 or 1. Okay, but carbon has how many electrons in their outermost valence band, outermost valence shell? How many electrons does carbon have in the valence shell? What is the atomic number of carbon? Andy, you can check your periodic table. You can check. You can Google.
Oh, okay.
6.
No need.
Carbon
Yeah, 6.
6.
Carbon 6. Okay. So if you arrange it in the shell and orbitals, what will be the configuration of the electrons in the shell and the subshell? 6. With 6 electrons. Where are they located? In which cell? In which subcell?
In the in the p orbital.
Yeah, P. Yeah. Can you write down? You may share the, or you may write down in this presentation, yeah, as annotation, using annotation.
It's
Yeah, yeah. 1s2, okay. 2s2, so 4. How many more? 2p, so 6.
yes.
Okay, 6, yeah. 1s2, 2s2, 2p2. Okay, so in the outermost shell, how many electrons does it have?
4.
4. How many electrons does it need so that the subshell P can be completed?
4.
4, also 4. Okay. So based on this, can you explain now why diamond is insulator, yeah, while graphene is conductor for electrons based on this electron configuration?
Because on the valence electron, they have 4 electron. So to become stable, they can either attract 4 more
Yes.
electrons to make 8, or they can lose the 4 electrons.
But to lose 4 electrons is not that easy because these 4 electrons are located in the different subshell. Yeah? The electrons in the 2s2 is not easily given away because they are already stable in 2s2. The 2p2 may be, yes, given away. Okay. Okay. Later, when in the assignment, you may put this additional information that I asked, yeah, in your slide. Interesting, but please put why graphene is conductive compared to diamond, for example, although both are carbon-based compound. Yeah. So please later I will put this assignment in the Google Classroom. When you upload the slide, please put the answer to this question. Okay, thank you for group 2. I think that will be all for now.
Sorry.
Okay, so let's continue with the next material. Yeah, so we go. I will first